Hello Pirates, today is Thursday and we are looking at graphing because today and tomorrow we're going to be looking at graphs, and next week we're going to graph and look at data for a lab. And so we're going to be looking at basic reading graphs kind of notes, and we are going to be looking at how is data from scientific investigation graphed. So what do they put on the x-axis, what do they put on the y-axis? So with your notes, you can use this note template and print this out and answer your notes. Today you are not, if you're an e-learning student, you are not going to upload this to Schoology. If you are a face-to-face student, I will check this off in your notebooks in class. But e-learners, you are not submitting this one. What we're going to look at is just basics on how to graph scientific data. And if you can't print out the template, you can just take the notes in your notebook on this content. And if you are, if you're home for an extended absence, you can get these documents, when you come back to school. So when we're looking at this, today we're looking at dry mix. So dry mix is just an acronym that is helpful in keeping straight the dependent and independent variable, and it is also helpful in understanding where we are graphing data. So what goes on the y-axis and what goes on the x-axis during an experiment. So we're going to look at the dry first. And so in an experiment, when you guys think scientific method, there is always a dependent variable. So we have the dependent variable. And the dependent variable, which my least favorite definition in a textbook, is that it says the dependent variable depends on the independent variable, which is not helpful. What we need is a good definition. So the dependent variable is the responding variable. So the D in dry stands for dependent variable, and the R stands for that it is the responding variable. So this is the responding variable. And that is what we're going to measure in an experiment. So it is what is measured in the experiment. And where is it going to go? It's going to go on the y-axis. And that's the one that goes up and down. All right, so it goes on the y-axis. The mix is going to help us remember the independent variable. So up here we've got the dependent variable, it's responding variable, it goes on the y-axis. So depending variable is the response. It's the response to whatever is changed for the independent variable. So the M in mix, so mix down here is to help us remember the independent variable. So the independent variable. And this is going to be the thing that you're testing or the thing that you change in experiment. So next week we're going to run an experiment and we're going to change something between two of those groups that we're going to test, a control group and an experimental group. And the thing we change is going to be the thing that we manipulate. So this is the manipulated variable. And this manipulated variable is the thing that changes. It's the thing that's being tested. And maybe you've used that word before, manipulate. And manipulate means that you're changing someone's mind or you're having them do something that maybe they didn't want to do. So if we define someone as being manipulative, they would be changing your mind. They're making you do stuff you don't want to. So the x then is what axis it goes on. So it's going to go on the x-axis. All right, so brief roundup, the dry mix. Dry helps us understand the dependent variable. It's the responding variable, and it goes on the y-axis. The mix is for the manipulated variable, what we change, what we're testing, otherwise known as the independent variable, and it goes on the x-axis. So if we're looking over here at our little graph, just for reminders, the x-axis is across the bottom, left to right, and the y-axis is up and down. questions? All right. Moving into this next section now, we're going to look at some graphs to just apply this. So we're going to look at some graphs so that we can apply understanding the dry mix and understanding how to read a graph. So what we're going to look at next is we're going to look at two graphs. And in these graphs, we are going to be looking at factors that impact enzyme activity. So we're going to be looking at factors that influence enzyme activity. And we're going to look at them and understand them through graphs. So when we're looking at our first graph over here, I want to first look at the labels. So if I look at the labels, I can see that there is a title, and the title is that enzyme activity versus temperature. And so my y-axis says that enzyme activity is increasing as I go up, and across the bottom I have temperature. So temperature is often something that's changed in an experiment, and we want to see how something reacts or responds to the change in temperature. So independent variable, what is the temperature? And I can off the bat see that my dependent variable is how it's going to impact enzyme activity. So I've looked at all my labels. We're looking in degrees Celsius. And now I'm just going to kind of look at my graph. So I've looked at the labels. I want to look to see if there's any trends in the graph. So I'm just going to follow the line, and I'm going to notice that for the temperature, as temperature increases, so does enzymatic activity. So enzyme activity is increasing as temperature increases. And then, oh my goodness. After a certain temperature, it starts to drop off right here around 62 degrees. So this is something I'm also noticing. And so I can speculate that anything higher than here, it wouldn't work, and anything lower than here, this enzyme wouldn't work. So I'm going to answer the questions now that I kind of got an idea of what's going on in the graph. I'm seeing enzyme activity rise with temperature and then fall off. So reading the graph, I'm going to look for what is my dependent variable. So the dependent variable here is going to be the response. And so that is the y-axis. So this is going to be enzyme activity. And the independent variable is going to be on the x-axis. So the independent variable here, the thing that's being manipulated or changed is the temperature in degrees Celsius. So I want to take a minute and identify at what temperature does the enzyme function the best at. So when is it functioning at its optimal or best range? And so I'm just going to look here. I have the most activity right up here. And if I follow that line down, that's going to be around how many degrees Celsius? That's right, 40 degrees Celsius. So explain what happens to the activity of the enzyme as temperature moves further from the optimum point. Well, let's look at the graph. As the temperature moves from the best or optimal range, so here is the best temperature, the optimum temperature, the ideal temperature. As temperature increases, the enzyme activity decreases, and as we go lower than the optimal range, the enzyme activity decreases. So in this section here, you want to explain what happens to the enzyme activity as it goes outside of its optimal range. The last thing, you want to diagram what happens to the enzyme when the temperature changes. When the temperature changes, the enzyme is going to change its shape. Kind of like if you heat something up and it melts, the enzyme kind of does the same thing. The high temperatures cause bonds to change, and we call those changes denaturing. They change, they form different structures. So our enzyme that maybe once was shaped like this, once it gets heated up, so if we apply heat, afterwards it might be shaped like this. And now it no longer works. Okay, so the enzyme has denatured. that means that it has changed its shape. And the thing that caused the enzyme to change its shape was the heat. So the heat caused the process of denaturing. So the structure of the enzyme became denatured. It changed its shape. All right, so what I want you to do next is I want you to try this next one. So pause the video and try to do the next one without me and see if you can figure out what the title would be, the dependent, the independent variable, the pH, what temperature it functions best at, what happens to enzyme activity as the pH changes from that optimum best range. And then again, diagram what must be happening to the enzyme at different pHs. So pause and return. Okay, so looking at that enzyme real quick, what we have here is this enzyme worked best at a pH of 7. And the enzyme activity decreased the further we got from a pH of 7. So any higher than 7 or any lower than 7. And then when we diagram the effects, we saw a change in shape, that process of denaturing. And again, we went from an original shape to a deformed shape that is not functional. Okay. Any questions? All right. If you have any questions, anything that you want to go over, you guys are welcome to log in on Thursday at noon into Biology Live. I'm always there, always ready to answer questions that you guys might have. Tomorrow we'll do some graph practice. I hope you have a great day.